Ed left aerospace engineering in 1990 to develop next-generation digital dome theaters for science centers and planetariums. He founded Vortex Immersion in 2007 to bring immersive domes into mainstream arts and entertainment. Ed is passionate about the potential of AI technology to revolutionize out-of-home immersive experience. Ed, it's your turn.
Thanks, Leonardo. Appreciate it. This is really, for me, a very exciting space to be in. First, talk about what we're referring to here by XR venues. Extended reality, XR now we call it. It's really a catch-all term for VR, AR, MR, and like that. By venue, we're referring to both real and virtual environments. And that's really the hallmark of XR venues, is that we're able to integrate a real and virtual experience somewhat seamlessly. So in this case, elements of the real environment are mirrored in the virtual environment as digital twins, but also elements of the virtual environment are mirrored in the real environment through various display systems. So of course, you can attend one or the other. The real environment might be a show with Beyonce and 1,000 people paying a high ticket price, and then millions of people in the virtual environment or metaverse. This is just an example to illustrate what this might look like. This is a particular use case where we have an immersive theater space. It could be a dance party. It could be, as shown here, more of a theatrical production. And elements of the metaverse can be projected and reflected in this immersive display. But also performers on the stage might be mirrored in the metaverse as well. So this is, of course, an MPI project. And we're targeting use cases here for extended reality technologies applied to these venues. Of course, enhanced by AI, which I think is going to be very powerful applications in these venues. And of course, we're using this standardized AI framework that MPI has adopted. And each of these AI modules have standardized interfaces, input and output. So it can be a black box. We just know what we get in, we know the function, and we know what we get out. So the idea here is to have an open market of these components with standard functions and interfaces, but competing on performance. So these are the use cases we've looked at so far. Live theatrical stage performance, which is I'll focus on a little more. Esports tournaments. These tournaments have like 10,000 people, some of them. And they're watching two teams up on front on the stage competing, and the screen showing the game is projected overhead. You have retail shopping. Maybe you go shopping and you put on AR glasses, and your wife is there with you virtually as an avatar or a whatever, telling you what to buy. Of course, collaborative labs or workspaces, immersive art experiences, like you guys have seen the immersive Van Gogh type experiences. Dance party with a DJ, VJ. Maybe the VJ is both mixing the sound of the music and the visuals using gestures interpreted by AI. Live concert performances where the band can interact, or the immersive environment is interacting with the music, but also with the audience. And experiential marketing, branding, all kinds of events like that can be produced using these spaces. And of course, meetings and presentations and such. So, so we focused on the live theatrical stage performance as our first call for technologies. The purpose here is to define interfaces and functions, of course, of the AI modules, that facilitate a live multi-sensory immersive stage performance. One hallmark of these systems when you're creating a live stage show like that is extensive on-site show control staff are required to operate these systems. Theatrical stage performances, maybe Broadway theater, musicals, dramas, operas, whatever. They increasingly use digital technologies, digital sets, reduces the cost of mounting the shows. Instead of painting sets, you upload your sets from a hard drive. And the immersive display can actually serve as a portal into the metaverse. So this is an example of a system where here we have the virtual environment, metaverse, we have the real environment with the audience, and you have remote performers. Perhaps they're on the dome, or they're behind the stage, or they're in another country and they're beaming in through a virtual production stage, a mocap stage, or a volumetric capture where we actually capture a 3D full motion mesh model of the performers and then place them in a virtual environment. Also, we figure there's going to be a Web3, Web5, they like to call it now, truly decentralized backend and remote participants as well on mobile media or whatever, or AR. This is the interaction model that we've developed. Excuse me. In this case, we have a real environment and a virtual environment, but really it could be two real environments. It could be two virtual environments or any number of these interacting. But the basic model here, we are capturing data signals of all types from the real environment. This could be cameras on the audience, tracking on the performers on the stage, music, video, biometrics, any number of signals that we're pulling out of the real environment. We're capturing them, formatting them into data. Then we're extracting features according to a script, actually, so there might be certain features that we want to extract. And then we're interpreting those features. So if it's gestures, performers on the stage, maybe raising your hand in the air means it's time to make fire shoot out of your hand into the infinite space. So that's the feature extraction. The action generation would generate the fire effect and feed it both into the real environment, but also into the virtual environment. So when we generate an action, it can act on both worlds. And likewise, we're pulling data out of the virtual environment and can drive actions based on that as well. So that's the basic system architecture. And, the benefits here include orchestration of very complex cues that have to be executed as part of the live show. And these shows are often unable to program the show or bake the programming into sequence because it's live. You have performers spontaneously interacting on the stage. Sometimes it's a little longer or a little shorter. And the music and the lighting and the video and the audio and everything needs to follow the actual performers. So what you do is you have a lighting person on a control panel running the lighting. You have another person running the video. You have another person running the audio. You have maybe effects on the stage, little elevator platforms, robots or whatever. And all of this have to adapt to the pace of live performers. Well, with AI, we can do that with much reduced staff. And what this does is it allows us to bring large shows, complex shows, to smaller venues that otherwise would not support such a complex production because of all the staff required. And of course, audience interactivity is a key thing. Including maybe even using content that members of the audience have opted in to share. And in a sense, we're creating a direct connection between the show creator, the artist, and the participants who have come to participate in the show by consolidating all of these different modalities, experiential modalities. So as I mentioned, maybe the performer can control the music and the visuals and everything directly, almost like from their mind into the mind of the audience, more direct of a connection with the creator of the show, rather than having a huge staff have to be trained and everything. Performers can access massive data from individuals, from participants who show up, and maybe share some of their visuals. And next thing you know, you see some of your assets being riffed on in the show. So, typical setup here. You have the physical stage with performers. You have an audience, of course. They can be in real and virtual world, actually, maybe even streaming audience. You have lighting, video, and special effects. You have interactive interfaces for voting or for audience participation. Could just be waving your hands. Emergent behavior, if you're dancing like that, you are looking at emergent behavior of the audience. Multisensory experiential delivery system, biometric data from the audience or the performers can be used. You can put heart rate sensors in the chairs. So, and so the show operators can come in and augment the show manually, but the show's been trained essentially by the operators who don't necessarily have to go on tour. Also, the metaverse mirrors selected elements from the real environment, and that can be done through mocap, capturing the performers, turning them into avatars in the metaverse, or volumetric capture, as we mentioned. And the real environment mirrors selected elements of the metaverse. So you have a wraparound display as a portal into the metaverse, big dome, projection domes or LED domes. Stage floor set pieces can be projection mapped. You can have the audience wearing glasses for AR overlays. And of course, lighting and special effects can augment that. And the idea here is the physical stage and the set pieces on the stage blend seamlessly into this infinite virtual environment projected onto the immersive display. So you can't tell where the real world ends and the virtual world begins. It's just a Gestalt type experience. So, and then in our typical setup here, we have AI modules, and I'll show a bigger image of this in a minute. AI modules are extracting these selected features. Their AI modules are interpreting the features. Different modules are driving actions. The script and the cue list guides everything. As always, it's kind of like the blueprint of the show, if you will. And human operators are there to control the show flow, augment or override the AI modules as needed. This is a little more detailed look at this particular use case. And, it gets quite complex. There's all kinds of data that you might be extracting and chewing on. In this case, you have a visual scene description, like what is happening on the stage. We're also extracting the performer behavior. What are they doing? But also extracting participants' status. So the participants are being potentially part of the show or interacting with the show. There's also operator controls. We might still have a DJ, VJ, lighting person, show control person overseeing this, the AIs. And then, of course, this all feeds into now generating the experience. And also cameras in both the real and virtual world might be floating around and providing camera feeds for live streaming or whatever. So that's a basic reference model for this particular live performance use case. Of course, we have a disclaimer here. These use cases have, all of these use cases have involved potentially sensitive participant data. And, you know, if you've heard some of the complaints about smart cities or smart whatever buildings, some people call it the surveillance economy, you know, where there's cameras watching you wherever you go, whatever you do. Well, you know, we need to be sensitive around that. You know, we're not really addressing with MPI these processes that oversee the collection and processing of participant data, but we are very sensitive to this conforming with ethical legal constraints, you know, and of course you have intellectual property rights involved as well. So, you know, data security is really important. Proper opt-in, opt-out for participants. Excuse me, also training, testing of AI models. You know, this is a big thing. You just saw maybe what was that? The paper that was put out, Elon Musk and Wozniak from Apple and a bunch of top people in the field have called for a halt to training AI models beyond GPT-4 because of potential harm that might be caused if we don't get it right. And so that's important stuff, you know. So anyway, so the idea here is to do a call for technologies to leverage AI and XR to support this use case here, this particular live theatrical stage performance use case. And we're seeking to obtain technologies that support some or perhaps all of the functional requirements. So in other words, you might be working on just an element, for instance, the interpretation of mocap data from stage performers and according to standardized choreography taxonomies like that. So, you know, the one thing we need to know from proposers of technologies is that they need to let us know the availability of licensing the technologies if adopted. So, and of course, this is in conformity to the framework license to enable MPI to develop this technical specification. And yeah, I mean, we're looking forward to participation. We have a great group working on this. It's growing actually, and there's a lot of interest in this. There's big companies. You might have seen the Madison Square Garden's Sphere, which is a 17,500 seat digital dome using LED technologies, both on the inside and outside of the dome, opening in Las Vegas this September. There's a company, Cosm, that's launching digital domes with a lot of sports programming. So it's like you're there. So this is coming. These are next gen, you know, technologies, next gen out of home entertainment. So of course, we look forward to your participation. Hey, share the fun, build the future, MPI. There's the website, and here's our participants. I might have missed one or two, but yeah, that's what we're up to. And thank you so much. If you want to correspond with regarding this XR venue standards, reach out to me here, or reach out to Leonardo, of course. And yeah, thank you guys very much for your attention.